So as we introduced in the last video, in order to solve exponential equations, we are going to need logarithmic equations. And the inverse of exponents is logarithms or logs. So we're going to talk about that in a lot more detail here. So we're going to start by looking at the basic exponential function. So if we have y equals 2 raised to the x power. That's a basic exponential function. 2 is the base here. So really, we would probably want to make it even more general and say y is equal to a to the x. And that's our basic exponential function, okay? The points that this function will go through are 0, 1, right? If you plug in 0 for x, then you say, and you can do this with the 2 if you need to, 2 to the 0 power, or anything a to the 0 power is 1. So that's the point 0, 1. If you plug in 1, you get a to the first power, or in our case, 2 to the first power. So you get a, the number itself, the base itself. And if you plug in -1, okay, you're going to get a to the negative first power, or 2 to the negative first power. And as you know, that negative exponent flips the fraction. So you're getting 1/2 or 1 over a. So it makes the reciprocal. Okay, and then we know that we also have a horizontal asymptote at y equals 0 for our exponential function. So let's graph that. And the reason I wrote 2 to the x up here is so we could really just graph it without worrying about a's. Okay, so we have 0, 1, 1, 2, and -1, 1 over 2. Okay, you could put more points in if you want to, like 2. If you put 2 in, you get 4, right? So 2, 4, 3, 8. Okay. And this is our exponential function. Okay, and notice that we do have a horizontal asymptote there at y equals 0. Okay, so let's compare that to our inverse. Okay, so the inverse function is going to be y equals log base a of x. Okay, so the base is a still. Okay, but the x and the y, they really are switched. So the function that we're going to graph is y equals log base 2 of x. Okay, but this is the actual inverse of a to the x. So the points that we have, remember how you find an inverse, right? That's why we studied inverses before we studied exponents and logs, so you could understand the concept. Remember, to find an inverse, you switch the x and the y, right? So if the point was 0, 1 in exponential form, switch the x and the y, it's 1, 0 in log form. And then likewise, 1, a becomes a, 1. And -1, 1 over a becomes 1 over a, -1. Okay, so these are 3 points on the log graph. And then instead of having a horizontal asymptote, remember that would be the y equals 0, now we're going to have a vertical asymptote at x equals 0. Okay, so we're going to graph this, but remember, for every a, we're plugging in the number 2, okay, for ease. All right, so we have the point 1, 0, right there. We have the point 2, 1, and we have the point 1/2, -1. So that's right there. Okay, if we continued, remember we had a point at 2, 4. So the point on the inverse would be 4, 2. That's an easy one to find. And then remember we plotted 3, 8. So on the inverse it would be 8, 3. Okay. And then remember that we now have a vertical asymptote, so our graph goes this way. So, oh, those darn pesky vertical lines. Okay, so there we are with the vertical asymptote at x equals 0. Notice that this does follow the rules of inverses in that it reflects, the inverses reflect over the line y equals x, okay, that diagonal line. So that's our inverse graph. Doesn't really help us solve problems until we get a little farther into this section. So let's take a look at the two forms of equation, exponential form versus log form. If we have y equals a raised to the x power, then to translate that into log form, to solve for the x, we have log base a, notice the base is the same in exponential form and log form, of y equals x. In other words, we're switching the places of the x and the y, right? So in this form, the a is equal to the base, the x is equal to the exponent, and the y is called the argument, but I've also heard it called the solution, which I kind of like because argument doesn't make like a ton of sense, in plain English. So the argument or the solution. Over here, they are actually equal to the exact same thing. So the a is still the base, the y is the argument slash solution, and the x is still the exponent. And so something that we're going to work on understanding is that logs represent an exponent, okay? The log, this whole side of the equation is equal to x, and x is the exponent, okay? So logs are exponents. So that's, I think, can be a little tricky to understand, but it does help when we're going through and thinking about things. So these are the two forms of the equations, exponential form versus log form. I'll show you some shortcuts to remember how to change one to the other, but I'm not going to do that until we start doing some problems with them and see how they work and you get used to it.